All right, well, let's look at the first one here. So if I were to rewrite this in matrix form, 1, 4, negative 3, 3, negative 1, 3, 1, 1, 6. All right, first thing I want to do is find the determinant of my original. So I'm going to bring these two out here. All right, so I get my down diagonal. So 1 times negative 1 times 6 is negative 6 plus 12 plus negative 9. Minus, right, for the ups, I'm going to have 3 plus 3 plus, right, well, that's 12 times 6. So what is that, 72? All right, a lot going on there. So when I add these together, I'm going to get, let's see, negative 15 plus 12, that's negative 3 minus 78. Yuck. Yes. Right. Because I'll show you the two. You'll have to see the 2x2s. Watch the video. It'll make more sense. But 2x2s, you just do diagonal down minus diagonal up. But if you just did that here, you would be missing these 4. So we bring these 2 columns over so that every number gets hit. Okay. Now we do our substitution thing. So what variable do you want to solve for? The x, the y's, or the z's? X's. All right, so we're going to take this column, and we're going to substitute it in for that column instead. So instead of a 1, 3, 1, I'm going to have a negative 8, 12, and 1. And then everything else will be the same as what it was before. All right, so now I find the determinant of this one. So negative 8, 12, 1, 4, negative 1, 1. I go down diagonals. All right, so negative 8 times negative 1 times 6. Positive 48 plus 12 plus negative 36 minus my up diagonals. 3 plus negative 24 plus
288.
Yikes. All right. So what do I get over here now? So it'll be 60 minus 36 minus, what is it? 267. Mm-hmm. All right, so that's going to get me 243. Negative even. All right, so I have that. So that's my determinant for this matrix, but what we do in order to solve for x is we take the original one and divide it. Does 81 go into 243 evenly? Believe it or not, it does. 3 times. That's my x. So there's one of them. All right, now what variable do you want to solve for? The y. All right, so this time we're going to take this and we're going to plug it into this column. So this one's back to being a 1, 3, 1. But now my middle column is going to be the negative 8, 12, 1. Negative 3, 3, 6. All right, these two come over. And we find this new determinant. All right, 1 times 12 times 6, 72. Negative 8 times 3 times 1 plus negative 9 minus my up diagonals, negative 36 plus 3 plus, what is it? Okay, that sounds good to me. All right, so So what I've got here is 72 minus 24 minus 9. Well, so it's like a 72 minus 33.
39.
Minus. Now over here, I gotta have a lot of negatives. So when I add the opposite here, now if I divide that by 81, will 81 go in there? Negative 81. Will 81 go in there evenly? No, it won't. But I think it does simplify to a fraction that's not awful. Because I think I know they both have a 3 in common at the very least. So this is 72 over 27. Those both have a 9 in them, so an 8/3. It's not really bad. That's my y. Okay. All right, well, I have 2 of them now, so do I have to do that to find the third one as well? No, you don't have to. You can pick one of these equations up here and plug those 2 into it. Any of those that you like better than another? Bottom one's probably not too bad. So x plus y plus 6z equals 1. All right, well, my x was 3 plus 8/3 plus 6z equals 1. All right, well, if I multiply everything by 3, just to get rid of that fraction off, 9 plus 8, negative 8. Man, what's wrong with me? Minus 8 plus 18z equals 3. All right, so that's 1 plus 18z equals 3. Subtract 1. So 18z equals 2. Divide by both sides by 18, and z is 1/9. So where all 3 of these things are going to intersect is going to be 3, negative 8/3, 1/9. Yep. All right, on this one, we're going to try to do the same thing. So we're going to find my original determinant. So my matrix would look like a 1, negative 2, 3, 3, 1, negative 2, and a 2, negative 4, 6. All right, bring my first 2 columns over. All right, down diagonal, 6 plus 8 plus, so that's going to be 9 times a 4, that's a negative 36, minus my up diagonals, which are going to be 6 plus, bend that one, so that's going to be a plus an 8 plus a negative, let's see, that's going to be 36. Uh-oh. Okay, so let's see, 14 minus 36, it's going to be a negative 22 minus a negative 22. So when I add the opposite, I get 0. Now, I know that we can stop here, right? Because when I take those, it doesn't matter what happens, whatever I plug here into any one of these columns, right, and solve it, whether I get a number that's 0 or not, right, what's my next step once I find the determinant? Dividing it by the original determinant. So I'm going to have to divide by 0. Can't. So this one's not going to have a solution. Inconsistent. Is that what they say in the book? Well, we know what that means. It means that they're parallel. Right? Any other ones? Okay. Matrix algebra. I don't know that we're going to have enough time. Now I know that we won't have enough time to get through all of these, but I wanted to at least start it so that we have less to go over tomorrow. All right, so we'll get over some of these easy ones first. If you're adding and subtracting matrices, the matrices have to be the exact same size and shape. If they're not, then you can't put them together. All right, so these both have 4 columns and 2 rows, so I'm allowed to add and subtract these together. So when they say A plus B, it's really simple. All you have to do is just add the places that correspond with each other together. So A plus B, 2 plus -3 is -1. 4 plus 4 is 8. 8 plus this 0 is 8. And -3 plus 1 is -2. Down in the bottom row, 0 plus 6 is 6. 1 plus the 8 is 9. And 2 plus a 2 is 4. And 3 plus a 0 is still 3. And my answer will also be the same size and shape as the original 2 that were being added or subtracted. Yes, easy mode. You wish. Multiplication is awful. Awful. My least favorite.
We get to learn that?
Yes.
Yay.
Isn't it like opposite corners or something?
Yeah, it's not friendly.
It's like this times that.
I'm gonna start having nightmares about this.
He's chasing you.
Okay, so when I subtract them, it's really done the same way. Just a minus in between. So A minus B, 2 minus a -3, 5. 4 minus a 4, 0. 8 minus 0, still 8. -3 minus 1, -4. 0 minus 6, -6. 1 minus 8 is -7. 2 minus 2, 0. And 3 minus 0, 3. But it's still the same size and shape as it was with my original 2. So adding and subtracting real easy. You should be able to breeze right through those. Okay, scalar multiplication is not too bad. That's where you just have a number out in front of the matrix. So 4A, right, so that means that I need to take my A matrix here, which is 3, 1, 5, -2, 0, 6, and multiply everything in there by a 4. So I'm going to end up getting a 12, 4, 20, -8, 0, 24. So it's really like just distributing this 4 through all of this. Pretty easy. All right, and then you can combine the different things together. So if I had 3A minus 2B, that means I need 3 times my A matrix. So that's going to be a 9, 3, 15, -6, 0, 18, minus 2 times my B matrix. So I'm going to get an 8, 2, 0, 16, 2, -6. And then I would subtract those. So 9 minus 8 is 1, 3 minus 2 is 1, 15 minus 0 is 15. -6 minus 16 is -22. 0 minus 2 is -2. 18 minus -6 is 24. Easy enough? All right. What does that get us here? Oh my. All right, let's start with matrix multiplication then tomorrow. But there are some basic rules. But for these, size size and shape does matter, and it's actually more specific. But they don't have to be the same size and shape. In fact, a lot of times when they're the same size and shape, they won't work. Right? So in order for to multiply matrices A and B together in that order, the numbers of columns in A must be equal to the numbers of rows in B. All right, so if you look down here, my number of columns in A, how many do I have? 3. But how many rows do I have in B? 3. So I'm okay. But then your answer may not look like either one of these. right? Your answer, the product matrix, will be the size that is opposite the requirements above. So it's going to have the number of rows of A and the number of columns of B. So my answer for this one, if I were to multiply these two together, how many rows will it have? 2, and its columns? 4. So it's going to be a 2 by 4, which is not either one of these. Why I picked
It's a
these.
board.
Crazy. All right, and we'll go over the way to multiply these tomorrow because it's nasty. Okay. No homework tonight.